Welcome back. So, if I'm looking at a bunch of different minerals, there are some obvious ways to tell them apart. There might be some less obvious ways to tell them apart. And it's probably those less obvious ways that are actually more helpful than the obvious ways, the obvious differences. So let's talk about different mineral characteristics, shall we? The first thing that I typically look at when I'm trying to identify a mineral is its luster. Does it have a kind of shiny, reflective shine to it, kind of like polished metal, or not? So is it shiny like polished metal or not? So that's the first thing you can do to try and figure out if, or try to identify the mineral based on its characteristics. So some are shiny like metal, some aren't. So it's either metallic or non-metallic. There are some subcategories to those, but for the most part, we just focus on metallic or non-metallic. The next thing we look at, it's kind of hard for an introductory geology student to pick this out, but it's something called cleavage. Cleavage is the ability of a mineral to break along preferred planes of weaknesses in the mineral due to the chemical structure, the crystalline chemical structure. So in essence, it's how it breaks. It's how something breaks. If I were to take a mineral and smack it with a hammer, the way it breaks, that's its cleavage. Some minerals have one direction of cleavage. They form kind of these flat planes. You can just peel them off. Some form two directions of cleavage, so they're kind of flat on two sides when you smack them. Some have three directions of cleavage. They form like cubes on all sides. For instance, halite salt, which I mentioned earlier, has three directions of cleavage. Some have also three directions of cleavage, but they're kind of tilted. One way to figure out a cleavage plane is parallel sides. Parallel sides. That's one way I think of it. So looking at one direction of cleavage, the top plane here is parallel to the other side, the bottom plane. So that's one plane of cleavage. In this scenario, the top and bottom are parallel, and the sides are also parallel. So top and bottom, and then sides. So that's two directions of cleavage. The front face and the back face might be a little bit different. Three directions, they're parallel on all three sides. Left and right, front and back, top and bottom, in some way, shape, or form. With something like calcite, which is also three directions of cleavage, but a little tilted, they're still parallel. Parallel, 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 even though there's a tilt to it. They're parallel to the other side. So again, that's kind of hard for the introductory student to figure out, but it is a very helpful characteristic. How does a mineral cleave when you break it? Sometimes when you smack a mineral, they don't form nice flat sides, nice parallel flat sides. They don't have good cleavage. Sometimes they just, kind of the opposite of cleavage, is fracture. When a mineral breaks with really no pattern at all. You smack it and it just kind of falls apart. Like there's no parallel sides to it. Here are some great examples of things that have been smacked, but that just fractured. Another characteristic that is very helpful, again, something we might not think about, is streak. Streak is the color of the powder left behind on a porcelain streak plate when the mineral is scraped across it. So you're leaving behind part of the mineral on these streak plates, a streak. The color of the streak tells you, is a good characteristic of the mineral. For instance, this mineral on the right, which you can see is kind of a reddish-brownish color, when you streak it, forms a reddish-brownish streak. The mineral on the left is actually kind of like a shiny gunmetal gray, but when you streak it, it also has a brownish-red streak to it. So the streak isn't always necessarily the color that you see. So that's what makes streak actually so powerful, because in reality, these two minerals are actually the exact same thing. Just a little difference between the two. They're both hematite. Just different ways in which they formed gave them a little bit different characteristics. So if you were to look at them, you're like, oh, these are different minerals. Well, actually, they're the same. Streak may have helped you figure that out. So that's why streak can be important. Sometimes, again, the streak is the same color of the mineral. Sometimes it's not. Another characteristic that we look at to identify minerals is, of course, color. minerals come in all shapes, sizes, and colors, but this is typically the least useful in identifying many, many varieties of common minerals. Not that it's not useful, it's just that color can be the least useful. Because you see a color and you're like, oh, it's because of this color, it must be this thing. Well, this is a different color, it must be a different thing. No, there are some minerals that are all the same mineral, but they're all different colors. For example, this is all the mineral fluorite, and you can see the variety of colors that it's coming in. Kind of yellow, dark purple, light purple, clear, like a bluish tinge to it. So color will mess you up every time. So try to save color for one of the last things to help you identify a mineral. Because there's some minerals, not only are different minerals different colors, but the whole mineral can be different colors in one crystal itself. Ranging from a number of different colors, rainbow in colors. And this is, again, these are all the same mineral, but different parts have different colors to it. So that's why color is, not that it's not useful, it's just the least useful. And then another characteristic is hardness, how hard a mineral is. Hardness is different than how strong a mineral is. Hardness is a mineral's ability to resist scratching, to scratch or be scratched. And it's based on a scale from 1 to 10. So if a mineral is low on what's known as the Mohs hardness scale, closer to a 1, that's a very soft mineral. You could probably take your fingernail and scratch it. Whereas the opposite end of the Mohs hardness scale, 10, in this case would be a diamond. Diamond is the hardest mineral we know of on Earth. Nothing can scratch a diamond except another diamond. So therefore, a diamond can scratch everything. So what all minerals then are just kind of based upon this reference scale. There's not only 10 minerals on Earth, there's thousands and thousands of them. But this scale just references 10 different minerals to give 10 different somewhat common minerals to have some sort of reference scale. So talc is the softest mineral. So since your fingernail has a hardness of about 2.5, so any mineral that's softer than that, for instance, just gypsum or talc, can be scratched by your fingernail. However, you cannot scratch calcite. But you can take a copper coin, like a penny, and scratch calcite. But you can't take a penny and scratch fluorite. Fluorite, apatite, a little bit harder, but a steel knife and or glass is harder than both of those things. Feldspar, quartz, topaz, corundum, and diamond. So oftentimes what we do is use a glass plate, a glass scratch plate. So glass has a hardness of about 5.5. And so what we do, just as a quick reference, is it more or less, is it harder or less harder than glass? So we take these, this is a little piece of square glass, and we'll look at these in lab. So we look at these glass plates, we take a mineral, and we just kind of scratch it on this glass and see if it scratches the glass. If it scratches the glass, we know it has a hardness of 6 or greater. If the mineral does not scratch the glass, then the mineral has a hardness of 5 or below. 5 or below. So again, diamond is the hardest substance on Earth that we know of. So it can scratch anything. The only thing that can scratch diamond is another diamond. So, fun fact, if you have what you think is diamond jewelry and you're looking at the diamond and it has scratches on it, it's probably not a diamond. It's probably something else. Because the only thing that can scratch diamond is another diamond. Unless you got a box full of diamonds and they're all scratching each other, I highly doubt. But if you're looking at a diamond ring and you see there's a scratch right across your diamond, that ain't a diamond. Now, hardness is different than strength. If I were to take a hammer and smack a diamond, it would just crumble into a million pieces. That's not what I'm talking about. I'm talking about hardness, which is the ability to scratch or be scratched. That's what hardness is. Two different things. Okay? Some other interesting characteristic that some minerals exhibit are fluorescence. They fluoresce or glow when exposed to ultraviolet light, black light. Additional other characteristics include something called birefringent. When you look at an object, or when you look at an object through minerals that exhibit birefringent, you can see a double image. For instance, looking through this variety of calcite, as you look through it to the paper below, you kind of see that double image. It's birefringent. Some minerals are magnetic. They're attracted by a magnetic. Some are, some aren't. And some further react to acid. You drop a little bit of a very weak acid on certain minerals and they'll begin to fizz a little bit, bubble. They'll react when very weak acid is dropped on it. We use weak acid because if we use strong acid could eat through pretty much anything. But if we use very weak acid, then only minerals that are very weak themselves will react with that acid. So that's another little test that we use. And then, as odd as it may seem, taste, yes, taste. There are a few minerals that have a unique taste. So sometimes those minerals, you're like, oh, is it this or is it this? I don't know. Well, taste it real quick. Oh, it's got this taste. It's got to be this other thing. So some are kind of tricky. Some have a taste. Some have a little smell to them as well. So I have licked and smelled a number of minerals in my day. Before we proceed, let me give you another part of the super secret code. It is the number 5. You got me, the number 5. One more time, the number 5. So what we just looked at are the characteristics of minerals. So looking at all these different things will help us identify what particular mineral we may be looking at. As mentioned, there's thousands of minerals. There are a handful of more common ones, but there are thousands of minerals, and they all have different characteristics to them. And once we can figure out how to read those characteristics, it helps us identify those. Now, the reason it's important to be able to kind of just a small understanding of minerals is because minerals are the building blocks of rocks. And that's what we're going to get to in our next section. So when we come back for section 3, we'll talk about the 3 different types of rocks. Also, what they can tell us about natural hazards and disasters. Minerals don't really tell us a story too much about natural hazards or disasters, but rocks can. But in order to figure out what type of rock we have, in some cases, we got to know the minerals that make up those rocks. Because again, minerals are the building blocks of rocks. So let's pause here and I'll see you back here in just a second.